So next, I'm going to talk about the site remediation procedures. Okay, so site remediation means the cleaning up. Okay, cleaning up a contaminant. Okay, site remediation means cleaning up a contaminated sites. Okay. Okay. I'm saying binding time here means the contaminant does not immediately remove. Okay, contaminant does not immediately remove all pollutions. It's just mainly to stop the pollution. So we try to stop the binding time here means we try to stop the pollution. We try to stop the pollutions from spreading. We try to stop the pollution from spreading. Okay, so we can. So the contaminated groundwater is pumped out and treated. Okay, the groundwater must be pumped and treated. Groundwater must be pumped and treated to prevent spreadings. The capping means we try to minimize the surface water intrusions. Okay, so we need to place a cap. We need to place a cap on the contaminated area to reduce the rainwater enter. So this can also help to reduce rainwater entering the soil. Okay, so we cover the site and stop water from carrying pollutant away. Slurry walls. Slurry wall means the trench is filled with clay or some kinds of low permeability material. So we try to block the polluted groundwater from the moving sideways. Okay? So that's why I mentioned binding times. We try to stop the pollution from spreading with binding times. For example, like we try to the binding time for prevent the COVID-19 virus for spreading, right? So traditional method, for example, like digging up. Okay, so conventional cleaning up method means we try to treat or remove the pollutions using using some engineering methods instead of just digging up contaminated soil. Okay, or pumping up groundwater. Okay, so the digging up the contaminated soil or pumping up the polluted groundwater, we call this traditional method. We call this traditional method. Okay, we call this traditional method. Sorry, not instead of such as, I'm sorry. Such as, so we're using some engineered method, okay, such as digging up the contaminated soil or pumping up the groundwater. So we call this conventional. We call this conventional methods. Okay? So we try to remove or treat the pollution using the common engineering method, conventional method. Okay, such as digging up contaminated soil or pumping up polluted groundwater. In situ, that means in place. Okay, in situ means the pollution in place. Okay, without removing any soil. Okay, without removing anything. Okay, so in situ, in place, cleaning out method means we can use vacuum extractions or heat extraction, air stripping, or some kinds of biological treatment. Some kind of biological treatment. Okay? Okay, change this to such as, not instead of, I'm sorry, such as. Using engineering methods such as digging up contaminated soil. Okay? Okay, so we try to buy time. Okay, we try to buy time. That means we try to stop the pollution from spreading. Okay, so we pump the contaminants. We cap. Okay, we build up a story wall. Okay, with low permeability. Sorry, wrong spelling. With low permeability. Permeability material. We use some conventional cleaning method, such as digging up contaminated soil or pumping up polluted groundwater. in situ cleaning up method means in place, okay, without remove the contaminations. So we use vacuum extractions, heat extractions, air stripping, or in situ, okay, or in situ biological treatment. Okay, first I would like to show you what does vacuum extraction means. Okay, so the vacuum extraction and heat extraction for contaminants. So for vacuum extraction, simply we use vacuum. We use vacuum to pull polluted vapors. Okay, to pull polluted vapors out of soil. Okay, there are some vapors, 有些蒸汽有没有在那个泥土里面 ？So we use vacuum to pull the polluted vapor out of the soil. Okay, therefore this is good for volatile and semi-volatile contaminants. Okay, so it's good for the vapor, good for the gas. Okay, for example, like coordinate solvent, petroleum hydrocarbons, or mercury vapor, right? And vacuum is applied through the extraction wall. Okay. Now many site demonstrations around the world using this vacuum extraction. Okay, just like this. Okay, just like this. Just like this cartoon, right? So we use vacuum to extract the vapor. Okay? Extract the vapors. And you also need some vapor treatment facility to treat the vapor. Okay, how about heat extraction? So heat extraction is very similar. Okay, heat is active. So heating the soil. You add heat to heat the soil. Heating the soil makes contaminants evaporate more easily. Okay, please write this one down. So heating extraction means you add heat. Okay, you add heat. Okay, so heating the soil to make the contaminants evaporate, become a vapor. Okay? Then you can add the vacuum to pull out those vapors. Okay? So those contaminants becomes vapor. Okay, so the difference between vacuum and heated. The vacuum one doesn't add any heat. The heat extracted means you need to add heat and extract this vapor. Understand? Everyone okay? So you add heat to the soil. So the contaminants in the soil evaporates, become a vapor. Okay, and we can also use air stripping or spargings. Okay, spargings. Okay, we all know about the stripping. How about spargings? Sparging means we inject under pressures into the saturated zone. Okay, injection of air under pressure into the saturated zone. This is so-called sparging. Sparging. Okay, I wrote right down here. Sorry, I didn't see it. So you don't need to write this. Okay. So the first sentence here. This means sparging. Sparging. Sparging means you inject air under pressure into a saturated zone. Okay, so this is called sparging. So the next, what I need to do is I need to define what is saturated zone. Okay, so this is definition of spargings. Okay, the saturated zone means the soil area below ground water table. Okay, so where the posts of soil are filled with water. So in this area, we call it saturated zone. Saturated zone. Okay, so when we inject air into saturated zone, okay, when we inject air into a saturated zone, it will create bubbles. Okay, so you put air into saturated zone. You will generate bubble. You will generate bubble, underground bubble. Okay, so these bubbles any function of this bubble? Yes. This bubble will help. This bubble will help remove volatile contaminant. Okay, from groundwater and soil. Okay, so air inject into saturated zone. The saturated zone will generate this bubble. The purpose for this bubble is going to help remove volatile contaminants from the groundwater and soil. And usually it combines vacuum extractions. Okay, usually the vacuum extraction is used together to collect vapor. And we also add, sometimes we add oxygen. Okay, we add oxygen because it can help with biodegradations. Okay, oxygen is helpful. Okay, so sometimes we will add oxygen. So it help who? Help microorganisms. Okay, we add oxygen to help microorganisms with biodegradations. Okay, so this is the cartoon for air sparks. So you can see that we inject air, okay, and you will generate lots of bubble here. Okay, lots of bubble here. Okay, those bubbles will help to remove the volatile contaminants. Okay. So the next one is called bioventing. Okay, bioventing is a type of in-situ biological treatment. Okay, it's kind of bioventing is a type of in-situ biological treatment. Okay, so we inject. What do we inject? We inject oxygen. Okay, and sometimes we also inject some nutrients. Sometimes for microorganisms. Sometimes we also together with not just oxygen, also we inject some nutrients. Okay, into the contaminated soil and groundwater. Why? Okay, we inject oxygen and nutrient to help why we are doing this? Because we inject oxygen and nutrients to help microorganisms grow. Right? The reason we inject oxygen and sometimes nutrient because we try to help microorganism growth. Therefore, it can increase biodegradation. Okay, it's especially useful. So we call this bioventing. Okay, so bioventing means we inject oxygen and sometimes together with some nutrient, okay, to help microorganisms grow. Therefore, it can increase biodegradation, and this is very useful for some kind of in-situ biological treatment. We call this bioventing. Okay, so oxygen and nutrient injection to help microorganism growth. We call this bioventing. Incinerations. Okay, I heard the group 1 also present incineration, right? So incineration means burning. Incineration means burning. Okay, but we need to burn the hazardous waste at very high temperature. Not normal temperature, must be very high temperature. Okay, must be very high temperatures. Okay, so when you drive on the highway, you might see this, right? So this is a rock木栅 zoo. Okay, this is the木栅incinerators in southern Taipei City. Okay, next to it is the木栅 zoo. Okay, have you guys ever think about this? If you have ever think about this, please raise your hand. Okay, this is the incinerator. Not a totem in the 木栅路 not a totem in the 木栅路 不是木栅动物园的图腾哦。This is the 木栅 incinerators. Okay, the furnace. Okay, this one is next to the 木栅 zoo. Okay, so everyone before you leave Taiwan, I suggest you visit 木栅路. Okay. Okay, so next I would like to mention the types of the incinerators. Okay, there are many kinds, but two technology dominate the incinerators. The first one is called liquid injections. Liquid injection, and liquid injection occupy more than 90%. Okay, and another 10% is called rotary kilns. Rotary kiln incinerators. Okay, so there are two main types of incinerators. One is called liquid type. Okay, another one is called the rotary kiln. Okay, so let's see the liquid incinerator first. Okay, so liquid incinerator, right? So it's mainly used for, so this is good for liquid. This is good for liquid hazardous waste. Then this is good for liquid hazardous waste. Okay, for example, like waste oil, like liquid chemical. Okay, and even some contaminated, highly contaminated, toxic wastewater. Toxic wastewater. This is good for those things. So liquid incinerators is good for liquid hazardous waste. For example, like waste oil, liquid chemicals, and highly toxic wastewater. Okay? So let's see the diagram. Okay, so the procedures, the sequence is the liquid waste. The liquid waste, you see that? The liquid waste will enter incinerators. So the purpose for the incinerator is to burn. Let me change it right now. The purpose for this incinerator, of course, everyone knows, to burn the waste. Okay, and there another one is called quencher. So liquid waste enter incinerator. After that enters. So proceed enter this. The quenchers. The purpose for quencher is to cool the hot gas quickly. Okay, so liquid enter the incinerators, and after that go to quencher. The purpose for quencher is to cool the hot gas quickly. So after quenchers, go to scrubbers. So incinerator burn, quencher, right? To cool the hot gas. Next one, scrubbers. So the purpose for scrubber is to remove. Okay, let me write down here, okay? So quencher. Quencher is used to cool the hot gas. After that, scrubbers. Scrubber is used to remove acid gas and pollutant. So after scrubber, it will go to the dust remover. The dust removal. Try to remove particles, right? The particles after burning. The last one is stack. Stack is try to release the treated gas to the atmosphere. Okay? So now you know this guy is a stack. Okay? So this guy is a stack. Understand? This is a stack for the incinerators. Okay, let me repeat this. The liquid waste enter the incinerator, so incinerator burn at high temperature. At least 850 degrees Celsius for hazardous waste. Quencher. The quencher is the facility to cool down the hot gas quickly. Scrubber is used to remove the acid gases and pollutants. So after burning, it will generate some dust particles, right? So dust removal, of course, try to remove the particles as much as possible. So after that, the stack is used to release the treated gas into atmosphere. Okay, so these totems, okay, actually not totems, okay. So this guy is a stack. Okay, this one is next to the Muzha Zoo, Taipei Zoo. If you notice, okay, while driving on the highway. Okay, the last one we are going to talk about the rotary kilns incinerators. So what is this? Actually, this is a very large rotary cylinders. Okay, a very large rotary cylinder. Here's very large rotary cylinder used to burn hazardous waste. Okay, used to burn hazardous waste. Okay, so the hazardous waste will place into the cylinder. So you put the waste into this cylinder. Okay, I want to define this word, refractory. Okay, The refractory means the materials. This material can resist very high temperature. Okay, refractory means some kind of material can resist, can withstand, or you use this word, withstand, can withstand very high temperature. Okay, so we use that to make this cylinder. So this is not a normal cylinder. Okay, this is not a normal rotating cylinder. This is the rotary refractory cylinder. And we're gonna put the wax into this cylinder. Okay? So although this kind of insulator is less than 10%, but normally we use this to treat very tough. We use this to treat very toxic chemicals. For example, like PCBs. Okay, for example, like PVC. So, rotary kiln, although this one only occupies less than 10%, but this kind of incinerators is good for handling tough, difficult, toxic chemicals such as PCBs, such as PVC. However, there are some limitations. Limitation means disadvantage. This kind of facility can can be damaged. Okay, can be damaged by something called thermal shock. Okay, damage by thermal shock. Not easily. Okay, they can be damaged by thermal shock. Thermal shock means temperature changes suddenly. If the temperature changes suddenly, it might damage this cylinder. Okay, it might damage this cylinder. Okay, so this is the diagrams. Okay, student. So this is the diagram for the rotary cranes. So this is the rotary crane incinerators. Okay. Okay. So this is the rotary crane incinerator. So as I just mentioned, we put the wax inside these cylinders. Okay, and this cylinder rotates on its horizontal axis. So the temperature should be maintained. The temperature should be maintained around 800 degrees Celsius to 120 degrees Celsius. Okay, but however, it might be damaged if you change the temperature suddenly. Okay, and you need to incline this and make it rotary. Okay. Okay, so this is the real pictures for the rotary crane. So it's huge, not a small one. Okay, finally, chemical fixation. This is not finished. Okay, I'm going to finish the second part of the notes. Okay. Okay, so the chemical fixations. So the chemical fixation also got two names. One is called stabilization. Okay. The other one is called solidifications. Okay. So what does this mean? This means we try to add materials. So adding material. Adding materials to hazardous waste to make it become a stable, solid. Okay, so we add some material to make this hazardous waste become a solid. Okay, so this is so-called chemical fixation. Chemical fixation, also known as stabilization and solidification. Okay. Okay. Why we want to do this? Because we say lithium is the pain in the neck, right? So we want to make it non-lithium. Okay, we said lithium is the pain in the neck. Okay, lithium is the pain in the neck. Okay, it will contaminate groundwater. So we want to make it non-lithium solid. So there are some methods, for example, like Poland cement. So it's good for those things, like sludge that contains salt. Okay, we can also add lime or quicklime. Okay, we can also add some thermoplastic. This is good for some strong oxidizer in organic salts. Okay, and we might also add some self-seminations. Understand? Okay, so we already finished the hazardous waste, but I need to go back to. Okay, we are not finished yet. Okay, we still have two slides to go over, but I will not go over all. Okay, so let's take a 10-minute short break and come back. Okay, not finished yet. Okay, everyone, please go to download. Okay, please go to download these two files. Okay, we are going to finish. Okay, very soon. Everyone, please remember, I will post on the Moodle, okay? Stone， 那个我们作业是明天交，对不对？后天。对。明天会死的。